Hello students, let's discuss applications of uniform circular motion. Here a vehicle takes turn along a level curve path. When a vehicle goes around the level curve path, it should be acted upon by a centripetal force. This necessary centripetal force is provided by frictional force. How? Let's understand. For that, let's consider a level circular path along which a car takes turn along left side. This is the direction of a curved path. This is the direction of motion. As you observe student, direction of motion is on right side, while the direction of a curved path is on left side. The object has a tendency to keep its motion along straight path, which is known as the inertia. Due to inertia of the car, wheels pushes it towards right. But still, the car can take a turn along curved path. It is because there is a frictional force between the tire and the road pushes the car towards left. Here, I can show one more position of the car and the forces acts on the car. As we observe in the diagram student, frictional force is perpendicular to the direction of motion and directed towards the center of the circular path. As we know student, centripetal force is also perpendicular to the direction of a motion and directed towards the center. Hence, the frictional force provides the necessary centripetal force. In the absence of a frictional force, car would move tangentially. Now let's discuss more about the inertial force. The force which pushes the car towards left as the car takes a turn on the left side is known as the centrifugal force. The centrifugal force is equal and opposite to centripetal force. But note down student, the centrifugal force is not a balancing force of the centripetal force. It is because centripetal force and centrifugal force are not action-reaction forces. Condition for action-reaction forces is that they should be act on the two different bodies. But here you observe student, centripetal force and the centrifugal force both acts on the same body in the given example, that is the car. We know student there are three different types of a friction: kinetic friction, rolling friction and static friction. Here for the given example, we have to note down that it is the static friction that provides the centripetal acceleration. Static friction acts on the object when it is about to slide. That is, static friction prevents sliding motion. So in the given example, static friction opposes the motion of the car away from the circular path. The force of a static friction changes with change in speed. That is, the static friction take a value from the zero to limiting force. If the speed of the car increase, force of a static friction increase. If the speed of a car decrease, then the force of a static friction decrease. But it has a lower limit as a zero and upper limit as a limiting force. From this we can understand student, force of a static friction is a self-adjusting force. It adjusts itself with respect to the speed. Let's understand what is limiting force. Maximum force of a static friction known as a limiting force, and this is proportional to normal reaction between two surfaces in contact. Therefore, limiting force of a static friction F max is a proportional to normal reaction N. Therefore, F max is equal to mu s into N. But again student, you have to note down that the given formula is useful only for the maximum force of a static friction. If the value of your force of static friction is less than limiting force, then this formula is not useful. Mu s is the proportionality constant known as coefficient of a static friction. Now let's understand forces acts on the car. For that, we consider a car of mass m. Note down student, here I consider car as a point mass and not as an extended body. This car is moving along the curved path of a radius r with the speed v. Let's find the vertical forces acts on the car. Normal reaction act vertically upward direction, and that of a weight of the car acts vertically downward direction. Therefore, n minus mg is equal to 0. It is because no net acceleration along vertical direction. Therefore, n is equal to mg. That is, a normal reaction balances the weight of the car. Horizontal forces act on the car. Centripetal force, which provided by the force of a static friction, and another force is the centrifugal force, which is mv square upon r. Centripetal force is equal to centrifugal force. But remember student, this condition is valid only when the car is not sliding. That is, force of a static friction required for the circular motion is within the range of 0 to limiting force. Therefore, for the centripetal force I substitute force of a static friction, and for the centrifugal force I substitute mv square upon r. Now, let's find the maximum safe speed for the vehicle on the level curved road. We know student, the limiting force of static friction provides the maximum speed up to which the car can move along the curved path without skidding. Therefore, limiting force of a static friction is equal to m into v square max upon r. But we know student, formula for the limiting force of a static friction is equal to mu s into m. Let's substitute this value mu s into n in above equation. We have mu s into n is equal to m v square max upon r. We know student, in the given example, normal reaction balanced with the weight of the car. So let's substitute mg for the normal reaction. Mu s into mg is equal to m v square max upon r. Mass of the car get cancelled. You have v square max is equal to mu s into rg. Therefore, v max is equal to under root of mu s r into g. This is the maximum safe speed of the car along the curved road. Now let's discuss what happens if the speed of the car increase beyond the Vmax. Case 1. If the speed of the car is increased more than Vmax, the force of a static friction is not able to control sliding of the car. It means centrifugal force is not get balanced properly by the centripetal force provided by the force of static friction. Hence, the centrifugal force increase. Because of that, as you can see student, car gets slide outward, which increase the radius of the circular path. And because of that, centrifugal force again decrease. If this decrease in centrifugal force is back in the range of a force of a static friction, that is from a 0 to limiting force, then again the centrifugal force get balanced with the force of static friction. That is, the car start moving along a curved path of an increase in radius r dash. If the speed of the car increase more and more from Vmax, you observe that the car moves along the greater radius. In that case, centrifugal force is uncontrolled by the centripetal force and the car moves tangentially. So from this discussion, you understand student, the centripetal force and the centrifugal force are not action-reaction forces. Case 2. If the speed of the car is less than Vmax, in this case, centrifugal force decrease. As you can see student, speed is in the numerator of the centrifugal force. As the speed decreases, centrifugal force also decreases. As you observe, the car slides inward. Now the radius of the curved path decreases, and because of that, centrifugal force increase. Now again, the centrifugal force get a balance with the force of a static friction so that cars stop sliding and to move along curved path. At a high speed and a sharp turn, friction is not able to provide required centripetal force. It is because, student, for the sharp turn there is a very small space to increase the radius of the circular path. One thing that you have to note down, student, beyond the limiting force of a static friction, friction cannot be zero. Only the type of a friction get changed. That is, within the limiting force of a static friction, the type of a friction is a static friction. Beyond that, the type of friction is a kinetic friction. Kinetic friction is the friction when the one body is sliding over the other body. So student, remember, beyond the limiting force of a static friction, friction cannot be zero. Friction is there, only its type changes from static friction to the kinetic friction. Limitation of a friction force which provides the centripetal force for the circular motion of the object along curved path. Friction force is not reliable. At high speed and a sharp turn, friction is not able to provide the required centripetal force. Friction causes unnecessary wear and tear of the tires. Therefore, in order to take a safe turn on the curved road, the road surface is banked. So what is the banking of road? That we will discuss in our next video. Till then, thank you. Bye-bye. Do like, share and watch my videos.